Hello, everyone. Today we're going to be going over the 33s. The material should seem fairly similar to stuff that we have taught you before. All right, in this problem, we have three numbers. We're going to start with a set of numbers that all go together. So we're going to start with this 22.22 milliliters of magnesium hydroxide. Remember, the rule is you start with what you're not trying to find out. So we're trying to find out some stuff about the HCl, so we don't start with the HCl. So if milliliters are on top, then milliliters have to go on the bottom of the next step. This might be the point in time that you want to pull out your mole map. If we are on milliliter island, the only place we go to is liters. Our goal is to find out the molarity of the HCl, and so the two things that we need to know are the moles of the HCl and the liters of the HCl. So our problem, we're going to try to get the moles of the HCl. So we're not done yet. Whatever's on top of the prior step goes on the bottom of the next step. Those are the rules of factor label. For on liter island, we're going to go to moles of any base, and that's going to be moles of magnesium hydroxide. As you can see, I ran out of some room, which maybe you do too, so I use some arrows. Bring the arrow back in over here. Whatever's on top of the prior step goes on the bottom of the next step. So moles MgOH2. So we're on moles of any base island. We're going to go up to moles of hydroxide island. Whatever's on top of the prior step goes on the bottom of the next. And this is our neutralization step. Our next step is to moles of hydrogen ion island. Almost done. Moles of hydrogen ion go on the bottom because that's what was on the top of the prior step. And now I'm going to go to moles of HCl. So in this problem, again, I want to calculate the molarity of the HCl. I have the liters right here. This whole problem is going to get me the moles of the HCl. I'm going to grab a different color pen real quick. And we're going to go back and put in numbers. There's always 1,000 milliliters in a liter. Here we have moles over liters. That's molarity, and it's the molarity of magnesium hydroxide. The molarity of magnesium hydroxide is right there, and it always goes with the moles. So 0.140 moles per 1 liter. We go over here, we have moles to moles. This is asking over here on this step, basically how many OHs are there in MgOH. So there's 2 OHs for every 1 mole of MgOH2. This step is our neutralization step. It's always 1-to-1, and we circle it because it's key to everything that we do. And then here I have moles over moles again, so it's wondering how many hydrogens there are for every 1 HCl. I crunch these numbers, and I end up getting an answer of 0.0622 moles of HCl. I have to take that and divide it by my liters. Right here, they give us the liters of the HCl. So 0.0500 liters of HCl. I crunch that number and I get 0.124 molar HCl. I'm going to show you all this on the next slide. That's done a little bit nicer and neater for you to look at. So please pause the screen if you need to take a look at this. I use my mole map to get where I need to go. A lot of times in these problems, you simply have to ask you, what am I actually trying to find out, and find those parts. The rest of this is for you to do as homework. Have a good day.